Even with our limited algebraic ability, we can already solve simple equations. Let's look at a typical algebraic equation in one variable. Say 2x plus 7 equals 13. Now, an equation like this is not true or false as is. It is true for some values of x and not true for other values. For example, if we were to substitute in x equals 5, we would get 2 times 5 plus 7, 10 plus 7, 17, so it's not equal to 13. When x equals 5, this is not a true statement. If, however, we were to substitute in x equals 3, we would get 2 times 3 plus 7, 6 plus 7 equals 13. We would get a true statement. Okay, when we solve an algebraic equation, that means we're trying to find all the values of x, or whatever the variable is, all the values of x that we can substitute in to make this a true statement. Now, it turns out in this particular problem, there is one and only one solution to the problem. X equals 3 is the only value of x that you can plug in here and have this come out to be a true statement. There are equations that have more than one solution, but we're not going to be considering them in detail here. An example of such a problem would be x squared equals 4. In this particular case, x equals plus 2 is a solution. Also, x equals minus 2. Because plus 2 squared, which is plus 2 times plus 2, gives you plus 4 or 4. Also, minus 2 squared, minus 2 times minus 2. Negative times a negative gives you also a positive 4. Okay, so here's an example of an equation with two solutions. All the problems we'll be working out today, however, will have one and only one solution. Now, in this problem, the one and only one solution to this particular problem was x equals 3. This type of an equation will be called a trivial equation. Okay, it's one in which the solution is obvious. X equals 3. This is an equation, but it's one in which the solution is obvious. It's obvious the only value of x that makes this a true statement is x equals 3. Two equations will be considered equivalent if they have exactly the same solutions. Therefore, these two equations are equivalent. Our aim in trying to solve an algebraic equation is to transform it into an equivalent equation of a trivial nature, an equivalent equation whose solution is obvious. Okay, the way we will transform the equation into an equivalent equation whose solution is obvious is to use the properties of equality. Let me list them for you now. If A equals B, then 1, A plus C equals B plus C. 2, A minus C equals B minus C. 3, A times C equals B times C. And 4, if C is not equal to 0, then A over C equals B over C. What I am saying here is that if you have an equation, say A equals B to start with, you may add the same number to both sides of the equation and get an equivalent equation. You can subtract the same number from the same quantity from both sides of an equation. You can multiply both sides of an equation by the same quantity. In each of these cases, you will get an equivalent equation. And if, say, C is not 0, you can divide both sides of the equation by C. In each of these cases, you will get another equivalent equation. And our object is to systematically proceed from the original equation using these properties of equality until we eventually get a trivial equation for the problem, one in which a solution is obvious. The only way this is going to make any sense at all is if we actually work out problems. So let's try some. x plus 3 equals 8. Okay. We want to solve this equation. Okay, now you probably have been able to figure this out in your head, but let's approach this systematically. Okay, we would like an equation of the form x equals something. Okay, a trivial nature. So, we see on the left side here we have x plus 3. An ideal way of getting just x would be if we could subtract 3 from this side. However, in an equation, whatever you do to one side, you have to do to the other side. So if you want to subtract 3 from the left side, it's perfectly okay as long as you also subtract 3 from the right side. You must keep these things balanced. Okay? Whatever you do to one side, okay, add, subtract, multiply, or divide, you must also do to the other side. And remember, you can never divide by 0 in our mathematics. Okay, now x plus 3 minus 3 is just x plus 0, or just x, and 8 minus 3 equals 5. And we've achieved our goal of getting this down to the form of a trivial equation, one in which the solution is obvious. And of course, we are correct here. 5 plus 3 gives you 8, and it's the only value of x that would make this into a true statement. Okay, let's try another. X minus 5 equals 3. Now, if you notice back on this problem, what I did was proceeded in a horizontal fashion. I subtracted 3 from both sides like this. Okay, you can also do your work vertically. Most people find it easier that way. We would like, of course, to get x alone. We know that we could get x alone if we add 5 to both sides. In other words, we have x minus 5. If we added 5 here, we'd have x alone. But of course, you have to pay for that by adding 5 on this side as well. We add 5 to both sides, and we get x minus 5 plus 5, or just x, equals 3 plus 5, or 8. Okay, so you can do this either horizontally or vertically, but I think when the problems get a little more complicated, the vertical treatment is a little easier to follow. And of course, we can check our answer. 8 minus 5 gives us 3, and it's the only value that will work. Okay, 3x equals 12. Now, once again, our goal is to get x alone. X equals some answer. Okay, now, in the problems that we've had before this, we added and subtracted to get x alone. Here, however, notice that the 3 and the x are joined by multiplication. This is 3 times x equals 12. In order to undo that multiplication, I'm going to have to use division. In order to get x alone, I will divide both sides of this equation by 3. 3x over 3 gives me just x. 12 over 3 gives me 4. Of course, these problems are all rather simple. You could have done them just in your head, but I'm just trying to lay the groundwork for problems that will follow. Okay, let's try this equation. 4x equals 0. Once again, in order to isolate x, we will have to use division. Okay, we will divide both sides of this equation by 4, giving x equals 0 over 4. 0 over 4 is 0. If you have nothing, you divide it into 4 parts, everybody gets nothing. Okay, don't confuse this with 4 over 0, which is not defined. Okay, you can't divide by 0. 0 cannot appear in the denominator. You can never divide by 0, but 0 in the numerator is perfectly acceptable, as long as the denominator is not 0 as well. 0 divided by 4, as long as you don't have 0 in the denominator, you're okay. 0 divided by 4, nothing. You divide it up into 4 parts, everybody gets nothing. 0 over 4 is equal to 0. Okay, let's go back to the problem that we started the lesson with. 2x plus 7 equals 13. Okay, this is a little more complicated than the ones we've been working out. Our object, once again, is to get it down to the point where we have x equals some number, which would be the answer to the problem. By the way, we don't always have to get variables alone on the left side, say x on the left side and the number on the right side. If it turns out more convenient to get the variable on the right side and the number on the left, that's perfectly okay. If I have 4 equals x as an answer, I'll know that is also a trivial equation. 4 equals x, that means the only answer is x equals 4. That's okay. All right, now I'm going to work with the constants first. I'm going to try to get x alone here on the left and the constants alone on the right to get it in the trivial form. I will subtract 7 from both sides of this equation, giving me 2x equals 13 minus 7, or 6. Now I have 2x equals 6. To get x alone, I will have to undo this multiplication of 2 times x, which I will do by dividing both sides by 2, getting x equals 3, which I mentioned earlier was the only solution for this problem. Okay, when the problems stop being trivial, it's a good idea to check your problems. What you do is you go over to the original, go back to the original problem, 2x plus 7 equals 13. And we want to check the answer, x equals 3. So we substitute in, every time we see x, we substitute in 3. And we hope that what we're going to get is 13. In other words, we hope that this will work out to be a true statement. 2 times 3 plus 7 should be equal to 13. 2 times 3, that's 6, plus 7 should be equal to 13. And of course, this checks out. 13 is equal to 13. And you really should be checking all of your equations. Okay, let's try another one. 6 minus 3x equals 15. If you want to try these problems by yourself, you can, of course, shut the videotape off and turn it back on when you've finished. All right. We want to get x alone on the left and the variable alone on the constant alone on the right. Let's subtract 6 from both sides, giving us 6 minus 6, that's 0, minus 3x equals 15 minus 6, or 9. Now, to solve for x, to get x alone, we'll divide both sides by minus 3. Minus 3x over minus 3, we get just x equals, now plus 9 over minus 3, this division gives us minus 3 as an answer. There are different signs, plus 9 over minus 3, so the answer is negative, negative 9 over 3, or negative 3. And the check for this problem, this is what we believe to be the answer. We check. We go back to 6 minus 3x equals 15. We substitute in our value. We get 6 minus 3. Now, x is minus 3. This should be equal to 15. OK, 6 minus 3 times minus 3 gives you plus 9. 6 plus 9 should be equal to 15. And of course, 15 equals, and that checks out. 8 minus x equals 12. OK, we can subtract 8 from both sides of this equation, giving us minus x equals 4. All right. Now, this minus x is really minus 1 times x. OK? There is a coefficient here of minus 1. Minus 1x equals 4. And then it becomes obvious how to solve this. We would have to divide both sides by minus 1, resulting, now minus 1 over minus 1, that just gives you 1x, or x equals 4 over minus 1 plus 4 over minus 1, for an answer of minus 4. I won't be putting down all of the checks, but what you would do would be to say 8 minus a minus 4 should be equal to 12. 8 plus 4 should be 12, and of course that works out. Okay, let's try a problem in which we have variables and constants on both sides of the equation. Okay, now in this problem, it's up to you to decide what side you want to have the variables on and what side you want to have the constants on. All things being equal, we generally do put the variables on the left and the constants, we collect them on the right. Okay, we can start with either the variables or the constants. I generally prefer to start with the constants. I want to clean the constants off of the left side. So I will add 7 to both sides and get 3x equals 7x minus 3 plus 7 gives you 4. 3x equals 7x plus 4. Okay, now, we would like to get the variables all on the left side. So I will subtract 7x from both sides so that the variable term here will come back on the left side. 3x minus 7x gives you minus 4x equals, and this is just 0 plus 4. And then we divide both sides of this equation by minus 4, giving us an answer of just x equals minus 1. Don't think you're going to save time or save space by doing more than one step at a time. Okay, it's never a good idea. If you're adding 7 on this step, that's all you're going to do. Don't try to add the 7 and subtract the 7x all at once. You could wind up making big mistakes. Also, always keep in mind where the equal sign is in the problem. Okay, if you're adding 7 to both sides, make sure you're adding one of the 7s on the right side and one of the 7s on the left side. Sometimes in long problems, people tend to forget, and they wind up adding, say, the 7 to both sides, both 7s to the same side of the equation. Okay, keep in mind where the equal sign is, and always make sure that what you do to one side of the equation, you also do to the other. Okay, let's try this. 2 times 8 minus x plus 4 equals x minus 4. Okay, now you can have situations where both the left and the right side of the equation are fairly complicated and must be simplified, say using the distributive law and combining like terms before you get to the point, say, of the preceding problem. And then after you've done all the simplification on the left and the right side, you proceed to solve the equation. See, the first step here would be to distribute the 2 through the parentheses, giving you 2 times 8, 16. Take away 2 times x plus 4 equals x minus 4. Now, it's a good idea to combine like terms. In this case, we can do something on the left side. We can say 16 plus 4 gives you 20. 20 minus 2x equals x minus 4. All right. Now we can subtract 20 from both sides of the equation. 20 minus 20 gives you 0, giving you here minus 2x on the left equals x minus 24 on the right. Now we subtract x from both sides of the equation. Minus 2x minus x is minus 2x minus 1x, giving you minus 3x equals, the x's go here, and we have minus 24. Minus 3x equals minus 24. The last step to divide both sides by minus 3, giving you an answer of x equals plus 8. Okay. We divide both sides by minus 3, get x on the left. Minus 24 over minus 3 comes out plus 8. Okay, let's do another one of these. 5, take away, in parentheses, 3 minus 2x equals 3 times x plus 1 minus 5. Okay, now we have to simplify both sides before we actually begin to solve this equation. Okay, this is really a -1, which we're going to distribute through the parentheses. -1 times 3 gives you -3. -1 times -2x gives you +2x. Equals, the 3 is distributed through the parentheses here. 3 times x plus 3 times 1, using the distributive law, -5. Okay, now let's try to combine terms on the left and the right. 5 minus 3 gives you 2 plus 2x equals 3x minus 2. All right, now we're going to try to isolate the variables on the left side and the constants on the right. We have a constant here that we don't want, so we will subtract 2 from both sides of the equation. This will give us 2x equals 3x minus 4. Now we have a variable here, but we don't want any variables on the right side, so let's subtract 3x from both sides. 2x take away 3x gives you minus 1x equals now minus 4. And we divide both sides of the equation by -1, giving you a final answer of x equals -4 over -1 plus 4. Let's try to check this particular problem. Remember, you really should be checking all of them. Okay, let's start by rewriting the equation. 5 minus, parentheses, 3 minus 2x equals 3 times x plus 1 in parentheses minus 5. Now we have already decided that we think the answer is x equals plus 4. We will go through this equation. Every time we see an x, we will write a 4. This gives us 5, take away, parentheses, 3 minus 2 times 4 should be equal to 3 times 4 plus 1 minus 5. In this particular problem, you had variables on both sides of the equation. Every time you see the x, you substitute in the 4, and you hope that the left side and the right side will come out to be the same. Okay, you work with the left side by itself, you get an answer. You work with the right side by itself. Okay, you don't do things to both sides because we don't know if this is true yet. Just work with the left, work with the right, and hope that eventually we'll get the same answer on both sides. Okay, and of course in evaluating this, you're going to use order of operations. 5 take away. Now, in here we have 3 minus 8. The multiplication is performed first. You don't say this is 1 times 4. Okay? You don't do the subtraction until after you've done the multiplication. 3 minus 8. All right, this gives us 5 minus 3 minus 8. That's a minus 5. And on the left side, 5 take away a minus 5. That's 5, and 5 gives you 10. Now let's see what we get on the right. On the right here, this should be equal to 3 times 5 minus 5. That is 15 minus 5. And we also get 10 on the right side, so it checks out. We are now ready to solve word problems that give rise to simple equations. There are videotapes which are devoted exclusively to the solution of word problems or variable problems. I'm just going to do one now to give you a flavor for it. Okay, let's try this. Find 3 consecutive integers whose sum is 24. Now it's possible that you could guess at the answer, but we want to be able to work this out systematically. There'll be problems that you can't guess at the answer. Okay? It's very important that we work these out, develop some sort of a technique for handling these problems. Okay, what we're going to do is say, let x represent the first of these integers. Okay, we're talking about 3 consecutive integers. If x is the first, then x plus 1 is the second, and x plus 2 is the third. For example, if x were 20, x plus 1 would be 21, x plus 2 would be 22. Whereas we've set it up so that x, x plus 1, and x plus 2 represent 3 consecutive integers. If the problem had to do with consecutive even integers, then I would have them going up by 2 each time. Right? Even numbers are, for example, 2, 4, 6, 8. They're 2 away from each other. So I would have x, x plus 2, x plus 4, if this was a problem about finding consecutive even integers. Well, here we just want consecutive numbers, consecutive integers. Okay, now it says find 3 consecutive integers whose sum is 24. If these represent the 3 integers, then the equation is the following: x plus 1 plus x plus 2 equals 24. See, this word problem gives rise to this equation. And solving equations is what this videotape is all about. The sum of the 3 numbers is to be 24. The numbers are designated x, x plus 1, and x plus 2. 3 consecutive integers adding up to 24. We now proceed to solve this equation. Okay, we have x plus x plus x. That is 3x plus 1 plus 2 plus 3 equals 24. Okay, we can regroup the additions here, rearrange it till we get 3x plus 3. We now subtract 3 from both sides of this equation, and we get 3x equals 21. Divide both sides by 3. We get x equals 7. If you remember, back over here, x is representing the first integer, x plus 1 the second, and x plus 2 the third. So if we get the answer x equals 7, that means 7 is the first integer, 7 plus 1, or 8, is the second integer, 7 plus 2, or 9, is the third integer. Okay, so our answer, 7, 8, and 9. 3 consecutive integers, 7, 8, and 9. These are consecutive integers. Now, for a check for a word problem, you don't go back to the original equation and plug in the 7 and see if it comes out right. You go to the words of the problem. Okay? We want 3 consecutive even integers whose sum is 24. So a check, 3 consecutive integers whose sum is 24. Not even, just 3 consecutive integers whose sum is 24. Okay, 7, 8, and 9. Your check just means you see that they're consecutive, 7, 8, and 9. We add them up. 15 and 9 gives you 24. And that constitutes a check for this problem. And that brings us to the end of this videotape.